He's the director of machine learning engineering at Spotify, and you studied physics. And myself, I'm currently CEO and co-founder of Fonos, and I studied computer engineering. And I must say that I'm also involved in language and linguistics. So well, let's see in our conversation. Roberto, what is, can you tell us more about your background and role right now?
Let me see how that works. Yes, thank you, Nieves, for that introduction. And so, as you were saying, I'm currently a director of machine learning engineering at Spotify. My deal with machine learning and data goes back to my time when I studied my PhD. As you said, I studied physics first at the University of Valencia, and then I studied. I did a PhD in astrophysics at MIT, and there I started like connecting a lot with the world of data. There we were analyzing the images from telescopes to try to discover planets, and so it was a lot like just purely research trying to chase that discovery. But the tools that we were using there were already like very heavily connected to the things that we use in artificial intelligence, which I found fascinating over time when I started getting into this. And so step by step, I followed the trace of the data. I started pulling the string a little bit from my PhD. I went to my postdoc. Then I joined the first startup in California called Stitch Fix. And then after that, I worked for Netflix for a few years. Then moved to Spotify. There, I would still consider myself a data scientist, research scientist more than anything. And then it was at Spotify where maybe I joined more of the engineering side. And ever since then, I've been working there for now 5 years. Right now from Barcelona, and so I was lucky I could just walk here. I'm a Eixample local, so it was pretty easy to get here. So that's nice.
The key word in there was data. No? So artificial intelligence is a lot about data. No? That's important. And since when you have been working with large scale AI models?
Yeah, so I think it depends a little bit on how we think about scale, right? Like when I was doing my PhD, and it's now like more than 10 years ago, so it's been a while. I think that we consider that just statistical modeling, right? So the objective was more of understanding the size and the mass of a planet. So it was just all like observational and trying to understand things. And so there, the scale was, well, maybe you have tens of thousands of images of a particular star, and then maybe you have hundreds of thousands of stars. So to me, that was pretty scary already, that they were talking about big numbers. But then as soon as I started working in tech companies, things started going like crazy really quickly. And Stitch Fix, for example, was a company that would send you boxes of clothing to your home. And then essentially we had millions of users, and each one of them will get a box every week or two. And so the volume of data will start growing, particularly because you will have to think about all the potential interactions between your users and your pieces of clothing, which were like millions multiplied by tens of thousands, then that multiplication gets pretty big quickly. But then when I moved to Netflix and Spotify, similar, we're talking about 200 million users constantly interacting with the app all the time. And then companies like Netflix are constantly logging all of the things that you do on platform. They're not trying to be like necessarily like sneaky and try to like get hidden information. They're just mostly really curious about how you use the app. And so maybe in a single session where you're just scrolling up and down in your home trying to find that very elusive good Netflix show, then you might have like thousands of login events just for that single user on that single minute, and so that blows up. And so at there is when I learned you could have an entire squad or team of 6 engineers just creating one data table, because that was worth it, even the size and the millions that you will spend on that. And I think that for Spotify, it's a similar scale of Netflix. So I would say about 5 to 10 years. But I would say other companies probably on the scale of 15 years sounds about right, that they've been dealing with these large scale problems.
And how many users and which countries is present Spotify?
So I think I memorized this. And Spotify is in 184 markets right now.
Yeah.
And then we just released the last earnings call like a month ago, and I think we hit 600 million monthly active users. It's about a little bit more than 200 million of them are subscribers, and the rest of them are in the free product that we offer.
So we are talking about a huge amount of data, no?
Yes.
And it's a real challenge to tackle that and to try to learn from that, no?
Correct. And then this, even like the smallest things, sometimes just saving the data, it's already a massive cost. Like we had lots of conversations about like, do you really need to save all that data for that long? Like, and if you just stop saving some data set, maybe you save millions of euros. And so it's pretty delicate topic, yeah.
How important is machine learning and artificial intelligence for a company like Spotify?
Yeah, well, I work at the personalization mission, and we are the team that does machine learning. So I hope it's very important. Otherwise, my job will be a little bit at least. And you never know. Like things are a little bit complicated, but I believe it's very important. I think that something that we always get quotes from is the customer service. Many of the people claim that one of the reasons why they come to Spotify is because of the personalization. I think that easy access to the type of content that you like, particularly when you are in the act of like, I just want to listen to some music. Maybe you don't want to be scrolling like you do for Netflix for like half an hour, right? And so like you want to do it in like a few seconds and then like go for it. And I think it's important that we get all that information right in front of you. And so customer service surveys highlight personalization as one of the top reasons why people like Spotify, particularly because honestly every single like music streaming company has all of the music, and so the music is there. It's not about the content; it's about the accessibility to it.
So artificial intelligence for Spotify is like key to customer success, no?
Correct.
And since when Spotify is building machine learning and artificial intelligence models?
Yeah, I think that my intuition is that it has to be more than 5 years because I joined 5 years ago, so I know that. But probably about 10 years. I don't think they were one of the first ones to jump into the whole idea. I think that Spotify has a tradition of like curating playlists for editorial playlists for like different types of moments and situations, and so we still have a very strong editorial content that team that really tries to build experiences for everyone. That's why like certain playlists are famous, like Rap Caviar or like any of the top music that we have there. But I would say eventually they realized that like all of the users were creating playlists. And then in that moment where you are creating a playlist, you don't realize that, but you're telling Spotify what's the connection between all of those songs. All of a sudden, you might create a playlist that's like hits from the 90s, and then Spotify could just filter by the time of delivery of the song and say, yeah, these songs are from the 90s. But you might say things that remind me of my summer in Alcobendas, or something like that, and then the connection you might make there might not be actually that easy to make for Spotify. So I think that's where it all started, when they realized that connection.
Yeah, it's like not specified data, but that is comes from the behavior of a certain group of users, no? And that's the magic of patterns and data and artificial intelligence.
Correct. I think there's always, from what I can tell, every single these tech companies that work with big data, they had at least one, but multiple aha moments where they realized, well, people are telling us very loudly that this thing works this way. Can we use artificial intelligence to build it at scale and then have everybody having access to that shared knowledge across everybody? And so I think that moment for Spotify was the moment where they realized these playlists actually contain the knowledge of how music is connected, which was very different from Pandora. At that time, I don't know if Pandora ever came here, but in the US, Pandora was the biggest thing because they really understood music, not from the playlist point of view, but actually the content of the music itself. And so they had a recommender system that was based on the music and its content, but we had it based on the playlist. And I think over time, it made more sense to base it on the playlist.
And in the end, people use a lot of Spotify, no? And Pandora is another place. The key of success, the aha moment.
Aha moment for that.
Yeah. I would like to talk more about use cases. It's true that artificial intelligence enables many use cases, no? From broader to narrower applications, artificial intelligence is not a new thing, although maybe people think on ChatGPT, but artificial intelligence is more of that, no? For example, at Fonos, we allow users to clone their voices, no, with artificial intelligence and use this model to create content in Spanish or to use it in other languages. No? We allow people to speak or communicate in a language that even they don't speak. No? So it's like it's magic for many users. And maintaining their identity. No? So for Spotify, what machine learning use cases do you think are key to provide value to users?
Yeah, because I think that when you were talking about what you all do at Sonos, that sounds really cool. I think that Spotify has use cases that could be similar to that, but they're very centered around the creators, right? Because if you're thinking about some sort of machine that allows you to translate content, we give a lot of we want to be a platform. We give a lot of power to our creators to control their creations, and so I think recently, and you pointed out in some of our conversations, they have this new technology to translate podcasts in different languages, and they can do it with the voice of the creator. So the creator doesn't need to speak Spanish, but they create the podcast in English, and it automatically goes into Spanish with the translation. So that's very cool, but it's very centered around the creators. I think that we use a lot of machine learning to help the users. Mostly the core comes from these content recommendations that we were talking about, right? Like we want to make sure that when you like go into a random radio, this is what I do a lot. I am in a mood and my mood is expressed by a song, and so I go look for that song and then say, play me a radio with this song. The rest is going to be created by an algorithm, and so that algorithm really needs to understand your taste and how all those songs are connected and how to create a good session. And so I think that that's the core one, what I would call recommender systems. And then on top of that, we are using machine learning in many different places. My team, for example, focuses a lot on understanding user satisfaction. And so we want to use artificial intelligence to try to understand why users are retaining longer than others. And so is it because they listen to all types of content, or is it because they know that our app is rich in functionality and they might be using different things, and other people that are maybe less advanced users maybe churn faster, things like that. And so that's another place where you can draw a lot of value from your algorithms in general. Yeah, I think for a company like Spotify, this is key to improving internal operations, no? And to understand if some new features are good enough for the current users, or to if the new features improve some behavior that users currently have, no? And strategy is key, no, for that. Do you create machine learning models with users' behavior data to learn what features are needed in the product? Do you have some example of that? Yeah, I think that there is a little bit of that going on, where I think that what the standard classic artificial intelligence helps you more with is with knowing where you want to double down. And so it's strange, the situation where an algorithm tells you you should start investing in this new thing that you've never done before, and then go do more of that. That's why you have like product managers, for example, like product leaders that can try to understand the landscape of the technologies that are being built, right? And so classically speaking, it has always been more in the direction of like, I have this algorithm that's telling me that users really like short-term content, right? Like they like to interact with like only parts of a podcast or something that's like a bit more easy to consume. And so then you form a hypothesis that that the product leads can follow based on the data, and then create a little bit more. And so I think it's a little bit more of that hypothesis creation, and a little bit more on the doubling down. But nowadays, I don't know. Like every now and then, I ask ChatGPT, can you write the product strategy for my team? It's actually pretty decent. Like I kind of get scared when that happens, but I feel like that we're a little bit far away from that. It's a bit more on the what's working right now for your company. Let's double down on some of that.
Yeah. I was thinking about advertising too, no? Do you have the Spotify? Well, in fact, you have a free trial for some users, no? That is monetized by ads. Is machine learning important for that?
Yeah, I would say it's very important. At the end of the day, you have a business model that is the basis of how you're serving the content to people, right? And we know that music cannot be free, right? Like you have to pay the artists that are creating the content. So you can have a premium subscription service that's clearly you can just share some of the revenue that comes from the subscriptions, and that's a good business model. But in the free side, you need to have some way of justifying the streaming of the music. So we do it through ads, and then once you are meant to have ads in the platform, machine learning can help you a lot to make sure that they're not as intrusive, right? Like you can personalize them, you can try to understand when is the right time to place them so that they're not as disruptive, and try to like help through that. And so it generally creates a lot of value. Once you are in the business of having to serve ads, it's good, particularly if you're just using some of the information that you have available. Like it helps you a lot to try to understand how to place them better.
More valuable ads for advertisers, for users, no? And it's so different from the radio, no? Personalization is key.
Everything is personalization. Once you get to that point, you really want to build an app that's different for each person. So,
yeah. And what about marketing? How can help machine learning to be more efficient in the use of your marketing resources?
Yeah, I think that's another place where this can help. I think that historically speaking, in these companies, marketing is valued through acquisition, right? Like you put a campaign, you want to attract new users, you want more subscribers, you want more engagement. But one thing that's very hard to understand is, are these users very similar to the users I have on the platform, or am I attracting that bottom of the distribution of people that barely like my product, but because I send them an ad, they decide to try for a little bit, and they're gonna get more of it. And so I think that artificial intelligence can help you predict the long-term behavior of these users, and through that you can understand if your investments in marketing are worth it or not. You don't necessarily want to go after any user. You want to go after the users that will make your business profitable over time. Because if you spend 100 million in marketing to get users that spend maybe 50 million during the first month, but then they disappear, then you just lost 50 million. So yeah, you kind of want to have that mentality of like, I need to understand their future behavior to know if it's worth it, what I'm doing, and then you can get a lot of help from these algorithms.
So artificial intelligence is efficiency. Sorry for my English. Efficiency too, no? Yes. So sometimes it looks like it's an investment, but the truth is, if you have data and you have like your hypothesis from the beginning, is a good tool and it's a good investment to improve in the end some operations and to make your users happier with your tool, no, and your product. We haven't talked about technology. We are talking about the value, no, that artificial intelligence has, no, in a product like yours. But it's true that artificial intelligence and all the technologies that lies below the umbrella of artificial intelligence is enabling new use cases day by day. No, it's like this new algorithm allows us to do this thing that before we couldn't do. No, for example, with voice cloning, 5 years ago, we used to have different technologies, neural technologies, that this is a huge step, that allowed us to imitate a voice, but we needed a lot of data. We needed, for instance, 10 hours, 20 hours of voice, recorded voice of somebody to be able to clone and to imitate. But in the end, this technology wasn't good with the nuances of speech, with the variability of how we communicate. So it looked like a robot, no? But now we have different technologies, generative AI, with diffusion models and adversarial networks and this kind of technology, allows us to imitate those new patterns and those nuances. And now cloning a voice requires only minutes. Is even second, but this with another kind of technology, no, with like large language models of audio, but you will only need some minutes to create a model of somebody, and it will look like more human and more like him or her. No. What about the technologies you use at Spotify? What kind of technologies enable those use cases we've been talking before?
Yeah, I think that in the case of maybe these more older school machine learning models of like that help with recommender systems and like understanding of the user, I think that a lot of that comes from like your ability to handle and process large amounts of data really quickly. And so I would say, I would say one of the differentiators is probably the time where everything moves to the cloud, right? Like I think that when I was a scientist, like I used to run my algorithms in my computer, and then every time you had to run a more complex like model, you just have to leave your laptop open during the night, and then you'll hear the fan going off the entire time, and then the room will be super hot. All that kind of stuff is gone, right? Like you don't have to worry about anything like that. You just like open up your favorite like cloud service, either Google or Amazon or Microsoft, whatever it is that you have, and then like you just go ahead and then request as much firepower as you need. And so that has opened up a lot of like use cases to be able to process so much data so quickly. And then through that, I think that lots of new use cases for us are being open with like real-time data or near real-time data where you don't have to maybe wait to react to the user interaction with the app, for example, right? Like many of these machine learning algorithms, they are trained on whatever you did last week, and then they react to what you're supposed to do today based on what they predicted. But then there are new algorithms that are capable of like reacting more live to what you're doing in the app. So there's a couple of things like that. But like lately, what's becoming very popular is pre-trained models, right? Like there's lots of like services that give you already something that's been built. That's like this is a model that understands how to do X and Y, and then so you can leverage that, put it with another type of model, and then you can build something even bigger. So I think that those things are changing the way we do this processing. And to be honest, it feels like you need less and less and less ability of hard like coding skills to be able to process these new models because so much of that is being built on the back end in some ways.
Yeah, it's like there are a lot of libraries and frameworks that improve, no? And you don't have to be you don't have to understand the in Spanish, no? The deep functionality of the algorithm or the model. You only have to know about the framework, no? PyTorch or TensorFlow or the frameworks that are built upon that, no? And you don't have to create like a neural network from scratch, no? As Kapati was, isn't it? um, and that was really interesting what you said, no? The differences of creating models that predict real-time user behavior versus a long-time behavior, no? And it's true that there's like a new wave of contextual learning, no? I mean, in terms of sometimes it's more valuable to understand why is the user doing that right now, because it might be so different from the week before because of everything, no? And that's so interesting. There are several fields that are focusing on context, no? To and interesting. How large scale models impact the design and implementation of those use cases in terms of technology election? I mean, is different from prototyping and so on.
Yeah, I would say so. I think that at the end you wanna take your development step by step with the right technologies, right? Like, and I think that at the beginning, when you are prototyping a first idea, what you want is full control of what's going on. You want to understand what's how your models are behaving, real examples, and so it's very nice to be interactive with the models that you're building. And so I feel like a lot of that development might be more on notebooks and like some places that are very easy to clean things and move things around. But then like the more that you're going through the phases of development of your particular algorithms, then the more then you have to bring in these big guns. Otherwise, certain things are not possible. In particular, once you have an idea, you want to test it. These tests are already pretty big scale. Like most of these big companies, when you test a new algorithm at scale, you are hoping you'll see a 0.01% change in this metric here and there. They're not gonna all of a sudden increase retention by 10% because those days are long gone. And so it's much more of a refinement, and then you need to scale like test them with a lot of users. And so already running a test, you need some sort of large scale infrastructure to be able to do that. But then maybe you're not so worried about incurring tech debt, and like you can maybe hack it a little bit more. But then once you know that your stuff is solid and you want to have it in production, then it's a new set of tools that come in that are much more about monitoring, control, and quality. And so every step has its own technologies that you sort of have to go through to get it to the end.
So this is also a challenge, no? So you have to have skills from all the life cycle of development, no? And you have to understand that you might learn something from the very beginning, from the prototype, but this might not be the same learnings from the next step, no? And you have to be all the time with looking for the learnings and looking for what have changed or might have changed, no? And that's a challenge too.
Yeah, it's a challenge, and I think it's a sign of a very like mature company when you are working on a project and then you are maybe 3 6 months in and then you realize, well, this doesn't quite work, and then you realize like, okay, we learned something, that's good, wrap it up, and then let's move to the next project. It's a little bit challenging, especially for the people working on those projects, right? Like you wanna be part of those projects that work well, but then if there's no like projects that go sideways, that means that you're not risking enough, and so there's like that side of that where you want to have as I don't know how many, but maybe, hopefully as many failures as winnings, and that's probably a good ratio of risk.
That's important, no? Failures. Because we are talking here about experimentation, learning, and this must have a failure, of course, no? And I understand that you try to also minimize the failures in this life cycle, no? You try to fail fast, just to learn as soon as possible and to change to another model or to try with another data, no?
Yes, I think that's the best way to go. And then I think that there's many places where you can catch yourself failing, and that's good. From the prototype state to like small scale testing to a large A/B test to finally even in production, you might actually get to a point where you put something in production and realize this actually doesn't work the way I thought it would work. And so I think that there's many places, and then hopefully if it's a bad idea, you'll catch it early. But the important thing is to catch it early.
Yeah, and to understand and to measure, no? All the time, what impact does the new algorithm have, no? And in the certain metric you are trying to improve or reduce or whatever, no?
Yes.
We're going good in time. I have more questions.
Okay.
And we can talk more about how do you learn whether a new machine learning algorithm is making things better. What kind of things are you looking for there?
Yeah, I think that it depends on exactly what you're doing, right? Like for the case of a recommender system, that's a little bit more obvious, right? Like normally what you do is you have two recommender systems that are competing with each other. They're trying to recommend content to the user, right? And so the first thing that you notice is that the user is more likely to engage with that recommendation, right? And if you have a homepage where users get in and look at the content, you can start measuring things like how many times they click on the content, how many times they actually consume that content over time, and that starts giving you an idea. Hopefully before that you've done your due diligence of like what we do in standard machine learning, which is more of understanding the accuracy and the predictive power of your algorithm. So you can do all of that offline, right? But I do think that the many times you might find that a model is more predictive or more accurate, but then the users really don't care. And if that's the case, then that maybe that you've reached your bottom, maybe, or your plateau for that development. But if you start seeing that, then that's a good sign. I think the what everybody's looking for is to then see the users behave the way you want them in terms of your North Star metrics, right? And so if you have like a service like Spotify, the most beautiful moment is when the users decide to stay longer in the platform, right? But that usually is harder to measure, takes longer, and then requires a lot of investment. And so you kind of want to find a place in the middle where you know that okay, these users are interacting with these recommendations more than before. They seem to be engaging more with the content, and I'm hoping that that means that they're happier. I think this is a good algorithm. But depends a little bit on the setup. Where you could get a little tricky is when you build a completely new technology and then the user gets surprised. Like, what is this? I don't even know what it is. And so sometimes they might react negatively for a week until they learn of the real value of that feature. So you have to be a bit more careful.
Yeah.
So different types of experimentation.
Yeah, users are like, we try to understand user behavior, but it's like sometimes it's chaotic, or sometimes users have children, it might happen different things, no? So it's like you are trying to understand why some things are changing, and trying to make your users happier, no, with that, and not to do things in the wrong way. No? And we were talking also about A/B testing, and I think that's interesting. Not so many companies do A/B testing. So how do you do, if you want to explain it better, how do you do A/B testing? And in which stages? Because you submit pre-production A/B tests and then production, no?
Yeah, I think that a company at the size of Spotify, particularly with our subscribers and our users all the time interacting with the app, it's a great opportunity to run A/B test. And so I think that as I was saying, maybe the first thing you do is you simulate an A/B test because that's cheaper, right? Like, and so you already have technologies that in some ways tell you if I run this test, I think this test is going to go well or it's not going to go well. That means that you can potentially evaluate thousands of hypotheses before you go into the test. And so, but granted, those predictions of whether a test will go well or not can be very, very noisy, and so you have to be a bit careful. But then that's when you jump maybe to your first A/B test, and I think that depends a little bit on the company. I think when I was on Netflix, they were very into canary tests, and so that's a bit more of the I'm just going to launch this test with like a very small amount of users to figure out the most basic things about the experience that are not breaking, right? That's kind of like a guardrail in some ways of saying, I know this test is not going to ruin it for everybody. And so you test it at small scale, and that test doesn't tell you anything about the metrics. It just tells you nothing's broken. And then you launch the A/B test at the end. That test, for in case somebody doesn't know, those are randomized control tests where you put people randomly into different groups, and then you compare the average behavior across the two groups. And because of this randomization, it really the only thing you're measuring, hopefully, is the cause effect between your changes from one of the groups to the other and the metric changes that you're seeing, right? It's very powerful. And it really tells you about the causality of what you're trying to do. And so you build it at a size that makes sense for the metrics that you're measuring. And then that's when you get product managers and data scientists and the engineers in the room saying, oh, this metric went up, this metric went down, this one. And then there's a lot of debate. And that's when you think, okay, this works. So then you move from testing on maybe 1-2% of your population to releasing it in 90 or 95% of the population and then holding back a few percentage of the population to make sure that you understand the implications of going large scale. And then when you do that, you do it, that's what we call a monitor rollout. And then you do it for like maybe 2-3 weeks. And then once everything checks out, then you know you got your win. And then you let it, you stop it because it's not scalable to maintain every single A/B test for a long time. And so at the end, you close it out. There's some cost associated with it, and so you finish, and then you're done with your development.
It's so interesting. I really love A/B test. It's pure science, no? It's like the best way to learn something, no? It's doing A/B test. I really love that. And you were talking about teams, no? You were talking about hey, the data scientists and when we talk about building large scale models or small scale models, when we talk about artificial intelligence, there are plenty of roles involved with different skills. No, as I started in the very beginning telling about statistics, linguistics, no, and physics. It's true that to build something, you don't need a huge team, no? Maybe with a small team, 3, 5 people, you can start having some really good models. I'm not talking about Spotify, meaning you can have a startup with, for instance, we are 5 at Fonos, no? So it's like you don't have you don't need a huge team, but you want Spotify. And as we've been talking that machine learning and artificial intelligence is key, you are a huge team of different backgrounds building things. I really love this concept in squads, no? What is a squad? Can you tell us more about that?
Yeah, I think that the original context behind the squad, if I understand it correctly, is a little bit surrounded the minimum size of a group of people that can effectively build a product and take it through all the agile stages, right? Like you wanna like ideate, you want the ideation, the testing, the building, and the shipping all contained within the same group of people, so that they can iterate much faster. That was the original concept, and so depending on the product that you're building, probably you'll get like the idea of having maybe 1 or 2 engineers. Maybe they're building some front end thing for the users to interact with. Then maybe you have some data engineers bringing in the data. Maybe a machine learning engineer that's building the models. A data scientist that's helping you understand the science behind it and the testing and the implications of the data that you're seeing. A user researcher that helps you understand how the users are going to interact with it even before you put it into testing, and then the product manager that's going to help you understand the product need. And so you start adding people. So it depends on the complexity of the project, but then between 5 and 10 people can form a squad, and then you get that group of people that can go round and round and round until they get it right. And then the most important thing then is to get them context so they can understand why they're doing what they're doing rather than micromanaging them all the time. Now, once the company starts becoming bigger and bigger, I think that there's even more of a need of alignment between teams. And so that becomes a little more complex when you have this sort of like squad concept. And then maybe you start introducing ways of alignment that's either through general company strategies that give people the same sort of context, or maybe building programs through program management that help in general. But the core idea for me has always been about the autonomy of that specific group of people. And so, ideally, if it was possible, then if Spotify has 1,000 engineers, then you have, I don't know, 200 squads of 5 people, so you'll have 200 products being built at the same time, something like that. And so then they can just continue building and iterating. But granted, you're going to have to take half of them to build a platform so that they can do it faster, and then it starts getting a little more complex.
Yeah, that's amazing. It's like a city of startups, no? Every squad might be a startup, but with different risks, no? And it's so interesting that they build in a context in which they have to be aware of, no? Because you have been telling me about to try to build something that improves a certain metric, this metric can be affected by different groups of people building different small features, no? So it's complex. It's complex and also funny, no? I think it's cool, no? To work in that kind of way, no? And what roles and skills are needed in a team like yours?
Yeah. So going in that direction, I think my team is very focused on like building machine learning models for user understanding and to try to help creators build audiences and like things like that. And so, generally speaking, we normally have a ratio between the squads of like maybe a couple of data engineers, a couple of backend engineers that can build the systems, and then a couple of ML engineers. Some of those ML engineers are very engineering focused, some others are a bit more scientifically minded. And then these squads feed from like other parts of the organization where you can get access to great data scientists that can help you with things, user researchers, and then a specific team that we have, for example, that does machine learning research. So then, if you are solving a complex problem, you can always tap into them, and they are in tune with the latest cutting edge research that is going on in the field. So with a little bit of that, like it's hard to fail because you have all the right mindsets and you can do a little bit of that. But I would say, yeah, a little bit of like software engineering, a lot of data engineering, and then certainly ML engineering. Some of the people that understand ML at scale.
And there's a thing there. You told me about people who is aware of the state of the art, no? Because this field is evolving so fast, no? I would say every 2 weeks, maybe, no? A new paper is published with a new thing that people have to evaluate and maybe get from that ideas to improve. Your own models and algorithms, no? So this is a challenge for you, I understand. And how do you tackle this and your group and your engineers? Yeah, it's a challenge for everybody. I think that it's a blessing for the researchers, right? Like they are the ones that, in some ways, maybe come straight from academia and they walk into a company to form their own like research groups. It's similar to what will happen in academia, but maybe they're a bit more applied than what you'll see in a university. Um, then you have the engineers that normally they have assigned roles that where they have to build something that's 5 years old technology, and they're already super excited about it because it might be the first time they do it. But then all of a sudden, there's a project that requires like 2 year old technology or 1 year old technology, and then is when they get super excited because like they know that in our field, if you get the chance to work on a new concept that's like more fresh, then those skills are going to transfer into the future. The career are going to grow faster, so they get super excited. The managers get a little bit more scared because they have to understand what their engineers are doing
and then they have a lot of daily responsibilities that be more on the management side, strategy, business, and so then on top of that they have to be understanding what their engineers are doing. But so it depends a little bit on the person. So I would say different like roles have different levels of adaptability, but in general, I feel like I've seen it myself, right? Like I would say our machine learning team or like the personalization mission probably has a spectrum from people that are working on 10-year-old technologies to 1-year-old technologies. Every time you give the chance to the engineers to jump, they're going to go in the direction toward the newer stuff. And so you kind of always have to have like constant flow of people that are excited about what was going on 10 years ago, because otherwise those would be the hardest things to stop. Everybody wants the thrill of something new. So that's exciting as well.
Yeah, and there's a learning curve there, that is so interesting. You play with something new, you really understand how it works, you enjoy building that, and you want to continue building that, no? And then you want another thing. There's a life cycle of a state of the art technology. And what advice or recommendation would you offer to professionals that looks to pursue a career like yours, no, to a similar path like yours?
Yeah, well, a similar path. You want to start physics and do a PhD in astrophysics.
In Valencia or
Yes,
not?
Valencia is a great university for
Yeah.
physics. There's some good professors there. But honestly, no. Actually, following my career is mostly following your curiosity, the path towards really what drives you and gets you going in one direction. So I think that I would approach this field always with curiosity more than very hard coded objectives. It's like, oh, I want to jump into this so that in 2 years I am working for Google with this type of title, and then I'm going to be doing X and Y, because that's very complicated. There's lots of different things and contexts, and like for example, in the last couple of years, it's very hard to get a job in a big tech company because most of them are kind of downsizing instead of like actually hiring. And so if that was your only objective, then you're set up for failure from the beginning, and that's challenging. And so I would say always curiosity, just learn as much as you can. And then I always recommend the people that are getting into this field is to try to understand what the role is really about, because from the outside it could be really sound really cool. Oh, I'm going to be building some generative AI models to teach Spotify how to speak with their users, and that's not nearly like what we're doing, right? Like we're probably doing something very different that's very more like down to earth, like as I was saying, churn modeling. That's the typical thing that they teach you in every Coursera class. It's like churn modeling, first thing. And so it might sound boring, but that's what's going to get you the job. And then you can continue growing your career, right? And so maybe a smaller company might be a bit more flexible to give you that chance, as opposed to just necessarily going straight to your like typical big tech company and then try head on. And so there's multiple ways, but yeah, patience. These things take time, and if the field right now is a little bit colder, then I'm sure that like 2 years from now or a year from now, there'll be a explosive growth of opportunities again. So it always fluctuates up and down.
Resilience, no?
Yeah, resilience is very important. Yeah, that's a good point.
Also for the algorithms and the state of the art algorithms and the frustration of this wasn't working out.
Yes.
And what about soft skills in terms of managing people? Because in the end, you are also having different squads on your chart,
Yes.
and understanding what they are feeling also, no? When they are building things, how do you have you learned something about
Yes.
that?
Yes. Yes. There's lots of learnings. I would say depends on where you are. In general, my feeling is that in this type of field, you need to get used to like managing dreamers, right? That's a big thing, right? Like you could technically build a team of like people that are just doing their 9 to 5, and then like building something that you're telling them to do, and kind of like if you were just hiring somebody from like in a website selling, I need somebody to code me this and this and this, very specific. That's not what these teams are about. They're a bit more of a, as we were saying, the squad, the core group of people that are trying to build something new. And so that's awesome in paper, but then handling a team like that is not trivial, right? Because as soon as you build something that's super cool, and then you have to go into maintenance mode where the engineers have to spend like months doing on call rotations to make sure that the system is working, then things get not so nice in that way, right? Because you might see the frustration of people that are like, but I already learned what I was supposed to learn. I already built it, it works. Why are you now making me spend 3 to 6 months getting the value, right? That's what the company wants at the end. So I would say understand your people and then learn how to rotate them sometimes. And there might be people that have to be 100% dreaming all the time, and then those people then are maybe better in a research team, right? You might not want to have them in an engineering team, but then always find ways to um, incentivize your people so that they keep feeling that they're growing. Otherwise, people are always expecting that they're going to be in the next phase of their career every 2 years, and so that's something that you have to manage. It's not trivial.
And it's not trivial, yeah. This is also a learning, a huge learning, large scale learning. Yeah. And let's talk. We are finishing. If you have any questions, we'll be in 5 minutes opening the mic.